1.6, represent functions as rules in tables. A function consists of a set called the domain containing numbers called inputs. Quickly. A set called the range. Containing numbers called outputs. And a pairing of inputs with outputs such that each input is paired with exactly one output. So notice that domain and input means the same thing, and then range and output is the same thing. The domain are the x values, the range are the y values. We have a way to represent functions called a mapping diagram. And with that, no input can have more than one output. However, there can be multiple uses of an output. So an example of a mapping diagram, we have inputs and we have outputs. So I have 1, 2, 3, and 4 for my input, and then for output I have 0, 1, and 2. And so 1 can be with 0, I can have 2 with 1, and then I can also have 3 with 2, and 4 can be with 2. So notice each input only has one output, but outputs can be used more than once. Something to note is that if an input is used more than once, it is not a function. So if they gave us a table of numbers and we have the inputs 3, 6, 9, and 12, and the outputs going across are 1, 2, 2, and 1, is this a function?
Yes.
I'm gonna vote no.
So if an input is used more than once, or any inputs used more than once?
No.
No. So then it is a function. And this is how I abbreviate function, FNCT. If you want to write out the whole word, that's fine, but that's how I will abbreviate it. How about this one? We have another input-output table. Let everyone get that one written down. Is this one a function?
Yes.
No.
Why or why not?
It only has
Yep. Input has 2. There are 2 2's there, so this one is not a function because there is a repeated input value. All right, a couple more definitions. An independent variable is going to be your input value this is what is being changed. So that's your x values. Your dependent value, or not value, dependent variable is your output value. And that's because it depends on the value of the input. So if they tell us to make a table for the function y equals x minus 5 with domain 10, 12, 15, and 18, and 29, then identify the range of the function. So my domain values are these here. So domain is the x values that I have. And that's going to be 10, 12, 15, 18, 29, then my range values are going to come from x minus 5, because that is y equals x minus 5. So I'm going to plug in this x number anywhere like for x here, and then I'm going to get out my y value. So this is going to be 10 minus 5, which is 5. So that range value is 5. I'm going to plug in 12 now. So 12 minus 5 is 7. Then 15 minus 5, 10. 18 minus 5, 13, and 29 minus 5 is
25.
24. So those values are my range values. Yes.
On the actual work, do we have to write down like 10 minus, something minus, anything minus?
Yes.
Whatever number.
Show your work. Because I need to know how you got there. All right, now into some book examples. So it's to identify the domain and range of the function. So they give us number 4. They give us a mapping diagram with the numbers 3, 5, 7, and 8. Output of 7, 5, 3, and 2. And they're connected with what's across from them. So, based on that, what numbers make up my domain? Just say it.
7, 5, 3, and 2.
Domain are what values? Somebody go back in the notes. What? The input values. So 3, 5, 7, and 8. My range values are what?
7, 5, 3, and 2.
Yep, 7, 5, 3, and 2. And you need to actually physically write them out. Some people go up here and they're like, I'm just going to say domain right here and range right here. Like, no, that is not sufficient. You need to actually physically write them out. All right, 6, they want us to tell if the pairing is a function. And since there was only one even one in the domain and range section, we're also going to say the domain and range of it. So they give us an input-output table. So, and just to be clear, if it's a table, whatever is beside it, or if it's like stacked on top of each other, whatever it's stacked on top of, that is like the pairing. But if it's with a mapping diagram, they're going to have arrows drawn to them so that you know what it goes with. So they give us 0, 1, 2, and 3, 7.5, can't write, 9.5, and 11.5, and 13.5. So first of all, is this a function?
Yes.
Why?
Because none of the inputs repeat themselves.
Yep, no inputs are repeated, so this is a function. So then, like I said, this question doesn't ask it, but just for practice, what are my domain values for this problem?
0, 1, 2, 3.
Yep, 0, 1, 2, and 3. How about range?
7.5, 9.5, 11.5, and 13.5.
Yep, everything out of the output column. All right, this next one's a multiple choice question. It says the domain of the function y equals 5x minus 1 is 1, 3, 4, 5, and 6. Which number is in the domain of the function? I mean, in the range of the function. Yeah. And they give us A is 0, B is 4, C is 9, and D is 15. So my x values that they gave me, 1, 3, 4, 5, and 6. Y is 5x minus 1. So if I do plug in each of these numbers for x, so I get 5 times 1 minus 1 is
4.
4. 5 times 3 minus 1 is 14. 5 times 4 minus 1 is 19. 5 times 5 minus 1 is 24. And 5 times 6 minus 1 is 29. So the answer is B. Now, obviously, if you were doing this problem, since it's multiple choice, as soon as you get one that's up there, you don't have to keep going, but just for the sake of practice, we kept going. All right, make a table for the function, identify the range. So it's essentially like these, but they gave us y equals, and then they gave us the numbers that we're plugging in. Yes.
How'd you get 4? No, like, how do you know which one is right?
Because that was the only answer option that was down here.
Ah, I get it. I'm dumb.
So 16, y equals 3x plus 4. Domain is 0, 5, 7, and 10. So I'm going to set up a table again. So I'm going to put those numbers 0, 5, 7, and 10. So I'm plugging these in for x. So 3 times 0 plus 4. 3 times 5 plus 4.
11.
11? It's 19.
I thought it was minus.
19. 3 times 7 plus 4.
So 25.
3 times 10 plus 4.
34.
Some of you are not paying attention, and I am going to tell you, if you come to ask me a question, I will not answer it because you are not paying attention. 18. Y equals 2/3 x plus 1/3. Domain is 4, 6, 8, and 12. So I want you to try this one on your own. And I'm going to walk around and look at them, so you need to be doing it on your own paper. All right, what range value did we get for domain 4? 3.
3, 4 and a third.
Hold on.
Okay.
What range value did we get for domain 6?
4 and a third.
4 and 1/3. What range value did we get for domain 8?
6. What's on?
5 and 2/3. What range value did we get for domain 12?
7.
I got 8 and a third.
It's 8 and 1/3. So, first one seemed like we were okay with. Second one, we had 2/3 times 6 plus 1/3, so that was 12/3 plus 1/3 is 13/3, or 4 and 1/3. For 8, we had 2/3 times 8 plus 1/3, so that was 16/3 plus 1/3, which was 17/3, or 5 and 2/3. And then for 12, we had 2/3 times 12 plus 1/3, which was 24/3 plus 1/3, which was 25/3, or 8 and 1/3. Any questions on that?
For number 8, when you have it in blue, like underneath the circled red, is that a 2/3 or is that 1/3?
2/3. And I would have just left them improper myself, as you can see by that's what I circled, but then I went back and saw that the book did mixed numbers, so I reread them. Any questions about any of this?
So if we do this, do you want them improper or do you want them mixed numbers?
I'll take it either way. I just like improper.
Use multiply across.
Yeah, that's what I did. I
You
always
put
just
8?
screwed up.
Okay,
Yeah,
let's
but
see.
you
Let's
divide
see.
it.
Same answer for every single
Well,
one.
you divide it, that's why.
No, you don't.
You don't divide.
I know.
You just said you do
obviously.
divide.
No, I'm saying I said she divided for every question.
Even my-
All right, your problems from this section are 3 through 17 odd.